Hey guys, what's happening? Today we have kind of an oddball concern. We have a 2004 F-150 5.4 liter 3-valve engine, and it has lean codes to it. Now lean codes are not common on the 3-valve engines. The old 2-valve modulars, all the time, intake gaskets, PCV lines, you name it. The 3 valves really don't have that problem. But there are a few points you want to check on there whenever you have these kind of concerns. And of course we'll go through the diagnosis real quick on this one, show you what I found and what I checked on the scan tool. So let's get to it. All right, let's go over the engine compartment here, and I'll show you a couple different items you want to check whenever you have lean codes on the 3-valve engine. Starting on the passenger side here, you're going to want to make sure that your PCV fresh air inlet right here is connected. You'll see it's connected to the valve cover and the intake here. And then of course you're going to want to inspect all your vacuum lines, okay, that go all the way around in here. The small vacuum lines, they can cause lean codes. And you're going to want to follow them up and around to the different components that they feed, including that black box back there behind the battery. That is a vacuum reservoir, and they like to split right along the seam on there, so that can be a good source for a vacuum leak also on these. Over here on the driver's side, there's of course the large PCV line. You want to make sure that's connected on both sides. The O-rings inside are intact and stuff like that. Vacuum lines here, they're feeding different components. This line right here is a vapor line. It's a vapor feed for the purge coming from the fuel tank. And as you can see, they kind of corrode, not corrode, but they kind of fall apart and just crumble from the vapors going through them all the time as it purges through. So these are pretty brittle, you'll notice on yours. So just make sure that it's not leaking and there's no holes in it, stuff like that. And it kind of follows around over to right there and plugs into the intake. Now, the other one you want to check on these is you see this huge booster line going down, the booster feed for vacuum. Well, it goes down and around and over and behind the intake and plugs into the bottom of the intake. They couldn't put it anywhere else, right? Well, those, they like to fall off. Okay, so back there it looks a little something like this. You have your rubber hose, your hard line, and then you have this rubber section right here. Now when these first came out, this was all just rubber, no clamps, and guess what? It would swell up from the oil that came through there, and it would just fall off. So you lose your brakes, or you start getting hard brakes, and you have a vacuum leak causing lean codes. So the new ones have all these huge clamps on them. Looks like some kind of torture device, right? And there was a recall, I think, for the 05s or 04. We did these for a long time that put these new ones on there to prevent them from falling off and leaking. So that is something to inspect. Of course, it is buried in there, so you want to check that last, but it could be an easy source of a huge vacuum leak. Now, the other one I want to talk about, and that is an oddball you may not think of. We had a message come in from the Ford FSC, and basically what they said is that these air filter boxes, you know, they came with a foam gasket around the bottom side here and up the sides here too. As you can see, after a couple of years, they crumble and fall off. You got some residue left. See how they crumble? Well, they were saying that because that was not sealing anymore, that the air would come in and the seal was not there anymore, right? And it would come past and it would swirl around as it goes up and past the mass airflow sensor, okay? And that would cause erratic readings, and it would cause P0174 Bank 2 lean. Why Bank 2 only? Well, it probably has to do something with the runner design itself. But that's something to consider as a last resort also. The one other thing, obviously you want to buy a quality air filter, because look at this one right here. You see how it's bowed in because it's actually caving in like that? Well, you're going to start to lose your felt seal around the top side here. It's doing the same thing back here. So that'll do the same thing. It'll allow unmetered air in, and of course it'll allow air to come in and swirl past that mass airflow sensor. Good items to check before just throwing expensive electronic parts at it. Besides that, let's go over to the scan tool and we'll look at a few things and see what's going on exactly with this engine. Okay, let's look at the code and the freeze frame data, and then we'll get to some live data, and I'll show you exactly what to look for on your scan tool on your truck. So let's go to the codes. And the first thing you'll notice here is that there's only one bank throwing lean. So you may think, hey, let's concentrate on one bank. No, this bank just went past the limits and set the code. Look down here at the freeze frame data, and you'll see bank 2 got about 28% of total fuel correction, and bank 1, look at that, it's actually past the limit right there. 20% is a limit, and it will throw a code. Okay, so right here, if you add bank 1's short and long terms, we're over, 24 on there, almost 20, 25. So right there, it tells you there's something in common causing this lean code. It's not isolated to one bank, like a intake gasket leak or something like that. And like I said, the 543 valve intake gaskets, leaking and causing lean codes I haven't yet to see one. Let's just say that. And these vehicles have some major mileage on them that I don't see it still, so not really an issue. Don't even worry about it. But freeze frame data right here, this will tell you all. Not to mention, look at the coolant temperature. We're full hot. So at that point, we still have a lean condition, and we're also, we're a little bit off idle here. We're going to actually set and look at these trims on here. So generally, it's not a vacuum leak if the concern is there over, 2200, 2500 RPM. This one case here is an exception, okay? And this has to do with the mass airflow sensor. This is why it's good to go in here and check and see what's going on before you just start changing stuff. And you can see all this stuff's pretty easy. It's a visual. We're sitting here on our butts playing with the scan tool, and we can really, diagnose it properly 90% of the time without even getting the multimeter out or anything like that. So the first thing you want to look at, the very most important part you want to look at, is the mass airflow sensor voltage. Nothing else. Forget everything else. We know the fuel trims are off. Let's look at the voltage. Bring it up on here. Now look at this. Right here, the mass airflow sensor is sensing something, and we're not even running the engine. Okay? It's stuck. 0.03. May not look like much, but believe me, it's going to throw out the calculation for the rest of the time the engine's running. So right there is a concern. It should say 0.00 unless there's air flowing past it. So right there, I know something is wrong. So you go ahead and start the vehicle. We're going to have our airflow. It looks pretty much right. You can see right there, we're at a higher RPM. We're about 1 volt. And once this engine settles and we're about 600 RPM, we're going to start seeing it around 0.68. Perfectly fine for this particular engine. And you'll see it as it idles down here. Most engines is 0.76, okay? But this one, it stays right around 0.66, 0.68. Now right there, our fuel calculation is actually off. Okay, we're reading a couple millivolts higher than what it should be. Okay, so let's go to our fuel trims. Just give you an idea of how much different this is. O2 sensors, we're not going to look at those. Want the short terms. I always have a problem finding the short terms. And you, of course, want the long terms. And this vehicle was, driven almost an hour to get here or more, so it's definitely learned at this point. Okay, so right here we're not doing too bad, but you can see if we add up the long terms and the short terms, we're closing in on 20 here. Now, let's give it a little bit of gas. Let's raise the RPMs up a bit. And you can see here we're at 6, 7, 8, 9% of the shorts, and same thing over here on the longs, so we're still above 20. And like I said, it's even on both sides. So you get a code for one bank, don't think it's just one bank. It's usually both. One just set it a little bit earlier than the other one. So by comparison here, I'll pop in a new mass airflow sensor. We won't clear the memory, and you'll watch these trims drop when it's getting the correct airflow rating. Okay, now removing one of these mass airflow sensors to either replace or inspect is very easy on these, right on top. So we'll have the key off. We'll take this connector off, pull back on the red locking tab, and then press down the black locking tang, and we can get it out. So let's take the T20, and it doesn't require the tamper-proof T20 like the older Fords did, just a regular T20. So we'll take it out. These have Loctite on this one. Usually they don't have Loctite on them though. Take these out. And you want to take it out and just inspect it. That's one of the first things you want to do, especially if you see that voltage is off. That's a real good tell right there. Key on, engine off. There should be no voltage. Now this one I pulled it out, and it's very obvious something happened to it because I could not get it out. Okay, it was sticking like right about here. They should come right out. Now this one. Okay. This one right here, you can see the case on it is actually split. You can see it right here. It's split and coming away. See that? So this one got damaged at some point, and it's just causing a skewed MAF reading. Very simple, very obvious. It's damaged. We need to replace it. For you, what you want to do is look at the hot wire sensing element inside of here. Make sure there's no excessive dirt on there. Something as small as a bug or a bug wing will cause lean codes. Believe me, I've been through it. Okay. So what you want to do is just give it a good inspection, make sure it's not damaged like this one is. And if it isn't damaged, before replacing it, you want to use a mass airflow sensor cleaner. It's made just for it, that will not damage that hot wire sensing element. Look at that, 4 to 10 horsepower. Oh yeah. So what you want to do is get the CRC MAF Sensor Sensor Cleaner, give it a good spray, let it dry out naturally, don't use compressed air. And then you simply want to reinstall it. You're going to reinstall it, recheck that voltage, and then you're also going to, clear your memory and start fresh and see what the fuel trims level out at. So for video purposes, we're going to put in a known good mass airflow sensor. Okay, we're going to pop it in there, we're going to bolt it up, and then we're going to go back over to the scan tool, and we're going to watch the fuel trims drop. We didn't do anything else besides put in a properly functioning MAF. Go ahead and tighten this up on here so it's airtight, and then we'll go test it. See what we got. Now this one, like I said, this is one of those situations where if you have poor, your fuel trims are off at idle and at a higher RPM, 90% of the time it's not a fuel issue and fuel quality issue. It really isn't. You want to look directly at the MAF. So that one's bolted back in. Let's connect it back up all the way. Lock it down, and let's go check it out in the scan tool. All right, here we go. We have the new known good mass airflow sensor in there. Let's look at the live data, key on, engine off. And we'll see our mass airflow sensor reading drop to 0. Once the scan tool initializes here. There it is. So 0.00. We're not flipping out. We're not fluctuating. We're not doing anything. Now watch. Now watch our fuel trims. They're going to start dropping down. You see them there? As it learns and the O2 sensors come alive, it's going to start dropping down. Right there, see -5, -6, -8, and it's starting to correct the long-term fuel trims here. And eventually they'll drop down and correct over time. But you see how they're both dropping, see how they're absolutely perfect with each other like this? That's because it's a common component affecting both banks. So as you go along here and you let it read correctly, it'll literally bring them right down to around, this truck leveled out around 10 or 8%, which is perfect, especially for the age of the truck. You can't ask for better than 8% correction. Anything below 10 I consider normal. When you get in the teens, I get worried. So this will just continually drop, especially, watch this, we'll get the RPMs up. Like before, it went to 20, 30 something. Look at this. Watch. You see how it is? It's -10, -14, because it's correcting for this up here, the long terms that were learned. So yeah, it corrected both our high off idle and our idle numbers here. Now, if you replace your mass airflow sensor, you want to disconnect your battery for 10 minutes or so and make sure you clear the old fuel trims and codes. I'm going to use the scan tool, do the same exact thing. We're going to reset the cam to keep a live memory. And we're going to start off fresh. After a scan tool replacement or even a cleaning, you want to start off fresh. Let the PCM learn the values, okay? Turn it off, back on, off. Now, let's go back up to here. We can get rid of the DTCs. They're cleared. Let's go back over to our live data here. And we know our mass airflow sensor is fine now. So let's go ahead and get rid of that. There's one other thing I want to show you, and that's the baro PID. The baro was the baro frequency PID is a known telltale that the mass airflow sensor is skewed in some way. So right now I just reset the cam and it'll always go to 149.74. Now if you're at a higher elevation, it'll be lower, and if you're at, sea level or around 500 feet above sea level, like we are in Chicago, it should come up to around 158, 160 even. Let's go ahead and start this and let it learn. So right now it's letting the O2 sensors come alive, and then it'll start correcting for the fuel here. This engine's got a horrible knock. I'm sure you guys can hear that. So right here you see we're hovering around 6 to 8%. Look at the difference right there. The one bank I know goes higher to around 10, okay? That is where that foam comes in. Also, this barrel reading right here, as we drive it and we learn it, it's going to go higher, and it will adjust the fuel trims also. So we may see 8, 10 right now, right? Combination, you see them changing with these when you add them together. We go for that drive, we learn this, these may end up around 5 or 6 long terms, while these are hovering right at 0. Alright, as you can see here, after our test drive, our baro did update to right around 158. It was still climbing, so that's perfect for this area. Our fuel trims, 5, 6, 7%, like I was saying. And of course our short terms are switching right around 0, perfect. So overall, this was a successful repair. We pinpointed the problem and we fixed the truck right the first time. Hope you guys enjoyed this.